Welcome to today's Friday Happy Math Hour. Today I'm going to cover sections 9.1, 9.2, 9.3, and a little bit of 9.4. This is from the Math 2412, which are sequence, series, and mathematical induction. Okay, again, these are the four sections that I'm going to cover: 9.1, 9.2, 9.3, and 9.4. So let's begin with section 9.1. Okay, this is the definition of a sequence. It says an infinite sequence is a function whose domain is set of positive integers. The function values are a1 through an, right? And it continues, right? You see, it goes an and then it continues. That means it's infinite. Are the terms of the sequence. When the domain of the function consists of first n positive integers only, the sequence is a finite sequence. On occasion, it is convenient to begin subscripting a sequence with 0 instead of 1, so that the terms of the sequence become a0, a1, a2, a3. Hey guys, if it's a0 first, that means this is your first term. A1 will be your second term, and a2 will be your third term, and so forth. But most of the times, they start with a1, so a1 is going to be your first term. Okay? Let's do an example. It says writing the terms of a sequence. The first four terms of a sequence given by an equals to 3n minus 2 are listed below. Okay? So here's my solution. The first term, right? I'm going to go to my sequence. I'm going to plug in 1 for every n, right? So if I plug in 1 here for the n, it's going to be 3 times 1 minus 2. The answer will be 1. That's my first term. A2, I'm going to plug in 2 where the n is. So I'll be 3 times 2 is 6. 6 minus 2 is 4. The third term, which is A3, will be 3 times 3, which is 9. 9 minus 2 is 7. And finally, the fourth term. 3 times 4 is 12, minus 2 is 10. So these are the first four terms of the sequence an equals to 3n minus 2. Okay, this is just similar to evaluating a function. Okay, but this is a sequence. It's very similar to evaluating. Now this is B part. It says the first four terms of the sequence are given by an equals to 3 plus negative 1 to the n are listed below. Okay. Here we go. So again, so to start out, right, a1 means I'm going to plug in 1 where the n is. So it's going to give us 3 plus negative 1 will give us 2. A2, I'm going to plug in 2 where the n is. So it's going to be 3 plus negative 1 squared is equal to 3 plus 1, which is equal to 4. A3 will be 3 plus negative 1 cubed, right? When the negative 1 is cubed, it's going to be negative 1. So this becomes 3 minus 1, which is equal to 2. And A4 will be 3 plus negative 1 to the fourth power. Negative 1 to the fourth power is equal to 1. So 3 plus 1 is equal to 4. Because if you notice, this keeps alternating, goes from 2, 4, 2, 4, and eventually that'll be the pattern. It'll just be 2, 4, 2, 4, 2, 4. Every sequence that is, for the term that is odd, it's going to be 2. Every sequence when it's even, it's going to be 4, right, and so forth. Okay, now here's example 2. A sequence whose terms alternate in signs. Okay, it says write the first four terms of the sequence given by an equals to parentheses negative 1 to the nth power over 2n plus 1. Okay, so I'm going to start with a1. Okay, I'm going to plug in 1 for the n is for the exponent, and also on the denominator where it's 2 times n. So I'm going to plug in 1 on both ends. So it's going to give us negative 1 over 2 plus 1 is equal to negative 1/3. Now a2, right? I'm going to plug in 2 for the n is on the sequence, on the given sequence. So it's going to give us 1 over 4 plus 1, which is equal to 1/5. A3 will be negative 1 cubed over 2 times 3 plus 1 will give us negative 1/7. Because if you notice, guys, look at the pattern, right? This section is all about patterns. You see, guys, you start with negative 1/3 and then positive 1/5, negative 1/7. So in this one, guys, it's going to be positive 1/9, right? Because it goes from 3 on the denominator, goes from 3, 5, 7, 9, and so forth. You see, it's going to be 1/9. So again, this section is all about patterns, okay? And the pattern here is the denominator are all odd numbers, the 3, the 5, the 7, and the 9, and the numerator, I mean, they're all ones, but they alternate signs. This is number 13 from the homework, okay? It says, write the first 5 terms of the sequence. Assume that n begins with 1. Okay, solution, okay? I'm going to plug in 1 where the n is for the first term. So it's going to give us 7 times negative 2 will give us negative 14. So A1 is negative 14. Now A2, which is the second term, I'm going to plug in 2 where the n is. It's going to give us 7 times positive 4 will give us 28. Okay. Now, okay, check this out. Without actually doing the work now. Okay, look at the pattern. It went from negative 14 to 28. Don't you multiply by 2? Right? Porque 2 is called my ratio. So the other one, A3, is going to be more likely negative 56 because 2 times 28 will give us 56, and they're going to be alternating signs. It's going to be from negative, positive, negative, positive. There's your 56. Now, the next term, right, because we already got the pattern, it's going to be 2 times negative 56. Right, which will give us, is going to be a positive number because it goes from negative, positive, negative, and it's going to be positive, I believe, 112. And the fifth term is going to be more likely negative 224. Okay, but let's make sure. You see, there it is. Okay, those are the first 5 terms: negative 14, 28, negative 56, 112, negative 224. Okay, observe the pattern. Alternating signs with the first term being negative, and every term is multiplied by negative 2. Okay, if the sequence starts with A1, okay, then a parenthesis negative 1 to the nth power will result in alternating signs with the first term being negative. You see, guys, this is like, right, if it starts with negative, and it's A1, right, so it's going to be negative, positive, negative, positive. That's what this, highlighted in yellow is trying to explain. Now, let's do number 14, which is write the first 5 terms of the sequence. Assume that n begins with 1. Okay, this is a pattern here. So A1 is going to give us 2 times negative 1 to the second power, which will give us 2 times 1 will give us 2. So A1 is 2. A2 is going to give us 2 to a negative 1 to the third power, which will be 2 times negative 1, which will give us negative 2. Okay, now guys, do you see this pattern now? You see, we're multiplying. It's going to go from positive, negative, and we're just getting 2, so it's going to be the third term will be a positive 2, and then the fourth term will be negative 2, and so forth. But let's see the work here. You see positive 2. Then A4 is going to be negative 2. Because every negative number to the odd power is going to be negative. And every negative number to the even power is going to be positive. That's why it alternates from 2 to negative 2. Okay, so this will give us positive 2. Okay, now look at the pattern. Okay, alternating signs with the first term being positive, right? My first term is positive. On the previous one, number 13, the first term was negative. Here, right? And every term is multiplied by negative 1. Here's the observation. If sequence starts with A1, then parentheses negative 1 to the n plus 1 power will result in alternating signs with the first term being positive. So every time you have alternating signs and you start with a positive number, this is what goes in front of the sequence, the negative 1 close parentheses to the n plus 1. And if it's negative, the first term is going to be parentheses negative 1 only to the power of n. Okay, and I believe I explained that in this slide here. Okay, let's see here. Okay, let's do A then. It says write the expression for the apparent nth term. Hey guys, here we're looking for the nth term. Okay, so we're looking for the formula of the sequence. So we do, right? We do, guys. We see a pattern. If we notice the difference is 2, right? From 3 to 5, the difference is 2 again. and factor 7, the difference is 2. Because this means there's going to be linear, something to the first power, because I only did one stage. So I mean, here, what we're going to do here, guys, we're going to put just an equals to 2n. Why 2n? Because we have a 2 here. This is my difference. Okay, but we have to, we have to check it out, see if it works. Okay, the first term has to be 1. So a1 is equal to 2 times 1, right, which is equal to 2. You see, it's not equal to my first term. My first term is 1, not 2. That means this is not the formula. Okay, now, but we know there's going to be 2n, because here, guys, the difference is 2, right? So let's try, if we go from 2 to 1, right, we subtract 1. Let's see if it works. Let's see, a1 is equal to 2 times 1 minus 1, which is equal to 2 minus 1, which is equal to 1. So that one works. Let's try the fourth term. If the fourth term works, that means that all these are going to work. Let's try the fourth term. This is going to be a to the fourth. The fourth term is equal to 2 times 4 minus 1 is equal to 8 minus 1, which is equal to 7. So this is my formula, guys. That's your formula. Okay. And again, say the difference was 3. Then it's going to be 3n, and then you adjust it. If it was 5, then it's going to be 5n. Okay. If it goes only to one stage, like here, right? If we find the difference on the first stage here, it's going to be something linear. And whatever the difference is going to be 2n plus or minus something, or just 2n. Okay. Let's try B now. Okay. Check B out. Good. Remember the signs? They go from positive, negative, positive, negative. Okay. So if terms have alternating signs, here are the two conditions. Assuming n begins with 1. Right? If you have parentheses -1 to the power of n, if the first term is negative. But here, guys, my first term is positive, so it's going to be the second one here at the bottom. If you have parentheses -1 plus parentheses to the n plus 1, that's what you put if the first term is positive. So this is going to go at the beginning of the sequence. So this is part of the sequence right here. Okay, now that we got the signs, let's see if we see some kind of pattern here. Right, from 2 to 5, right? Excluding the negative, it's going to be 3. From 5 to 10, it's going to be 5. From 10 to 17, it's going to be 7, right? And you notice, guys, it's going to continue. It's going to be 3, 5, 7, 9, and so forth, right? Now, let's try it again. From 3 to 5, right, it's going to be 2. From 5 to 7, it's going to be 2. Okay, now, guys, this tells me it's going to be quadratic. Why quadratic? Because we went 2 stages. You see, this is linear, and this is quadratic. Okay, require 2 stages to get the same difference. So this is going to be something like n squared. Okay, let's see if it works. Remember, my first term has to be 2, right? I know that we're alternating signs. So over here on the right, the n equals to -1 to the n plus 1. This will take care of the signs. Okay, so we just worry about the numbers. Okay, now let's find first a1. a1 is equal to 1 squared, which is equal to 1. Does that give me 1? No. Okay, so that's not the formula then. But I know it's going to be something squared. Okay, now let's see what we can do here, guys. How about we put n squared plus 1 to 1 with a formula that didn't work, right? To adjust it, we add 1. That way it's going to give me 2. Let's see if it works. I'm going to try the first term and the fourth term. So if we plug in 1 for the nth, it'll be 1 squared plus 1. It's going to give us 2. So that one checks out. Now let's try the fourth term. Okay, it's got to give me 17, guys, right? And then if it does, then this is your formula. So 4 squared is 16. 16 plus 1 is 17. So that's the formula, guys, but this has to be in the front. See, this takes care of the alternating signs. And for the numbers, it will be n squared plus 1. So this is the formula that we're looking for. Okay, now this is called, let's read from the beginning. Some sequences are defined recursively. To define sequence recursively, you need to be given 1 or 2 of the first few terms. Other terms of the sequence are then defined using previous terms. Example 4. It says a recursive sequence. says, write the first 5 terms of the sequence defined recursively as A1 equals 3. And the next term, AK, will be 2AK minus 1 plus 1, where K has to be more than or equal to 2. Okay? So just right now, guys, okay? So this is going to be my first term, right? My first term is 3. Now, let's plug into the formula, right? I'm going to put a 2 for every K, right? Because A2, I'm going to put a K, where the K is. So then it's going to give us 2A to the 2 minus 1 plus 1. Hey guys, A to the 2 minus 1, right? It's going to give you A1. So it's going to be 2A1 plus 1. And A1 is equal to 3. So it's going to be 2 times 3 plus 1, which will give us 7. Now A3, I'm going to plug in 3, where the K is. So I have 2, and I have A to the 3 minus 1 plus 1 is going to give us 2A, to the 2, right? To the second term plus 1. The second term is 7. So I'm going to plug that in for the A2. And then plus 1 is going to give us 15. Check this out, guys. Look at the pattern, okay? Here's the pattern here. If you notice, where it says A to the K minus 1, right? It means it's going to be the previous term. For example, right? An A2, right? We plug in 3 for the A to the 2 minus 1, right? Because 2A to the first, right, is going to give us a 3. And then for A3, we're going to plug in the 7 where the A2 goes, right? So that's why it's going to be 2 times 7 plus 1. For A4, we're going to plug in the 15. Okay. Now for the fifth term, I'm going to plug in the 31. So it's going to be 2 times 31 plus 1. You see, there it is, guys. So once you get the sequence, you don't have to do all that work. Just follow the pattern. And again, this section, guys, is all about patterns. Okay, chapter 9 is all about patterns. Let's see here. Let's try another one, guys. This is called the Fibonacci sequence. It's defined recursively as follows. Hey, guys, the Fibonacci sequence is a very important concept that like many plants and nature, follows the Fibonacci sequence. Okay, and how do we find it? Here is it's going to be amazing because it has a pattern. Okay, so this is a formula. A0 is equal to 1. A1 is equal to 1. So AK is equal to AK minus 2 plus AK minus 1, where K has to be more than or equal to 2. This is right, the first 6 terms of the sequence. Okay, here we go. There's my A0 is 1 and A1 is 1. So let's follow the formula here, guys, all right? So A2 is equal to 2 minus 2 plus A to the 2 minus 1. So A to the 2 minus 2 is going to give us A to the 0. And A to the 2 minus 1 is going to give us A1. So for A0, guys, I'm going to plug in the 1. And for A1, I'm going to plug in the other 1. So 1 plus 1 is 2. Now A3, right, is going to give us A to the 3 minus 2, which is equal to A to the A1. And A to the 3 minus 1 is going to give us A2. So I'm going to use A1, which is 1, and A2, which is 2, which will give us 1 plus 2 is 3. Okay, now, hey guys, look at the pattern. Okay, here's a pattern. Hey guys, what they do here, guys, they add the first 2 terms, right? 1 plus 1 is 2. And then they add the previous one, which 1 plus 2 is 3. Right? And then for the next one, it's going to be 2 plus 3 is 5. So the next one is going to be 3 plus 5 is 8. You see, because we get, the previous 2, before. We get the A3 and A4 goes here, right? So it'll be 3 plus 5 is 8. Now for A6, it's going to be 5 plus 8, which is 13. And let's do one more. A7 is going to be, let's see here, it's going to be 8 plus 13 is 21. You see, then the next one will be 13 plus 21 will be 34 and so forth, guys. You see, that's a pattern. It uses the previous 2, and then you add them. Okay. Okay, now, again, this is also recursive. It says, write the first 5 terms of the sequence defined recursively. Okay. they give us A0 and A1. Okay, here's the formula. Okay, here we go. So I'm going to plug in 2, because now comes my third term, which is A2. So I'm going to plug in 2 with a K, so it'll be 2 minus 2 plus 1/2 A to the 2 minus 1. So this is going to give us A to the 0 plus 1/2 A to the first power, right? To the first. So A0 is equal to 1, and A1 is equal to 2, so I'm going to plug him in there. So it's going to give us 2. Now let's find A3. Right? A3 is going to be 3 minus 2, A to the 3 minus 2 plus 1/2 A to the 3 minus 1. So it's going to give us A to the first, or A to A1 plus 1/2 A2. A1 is 2 and A2 is 2. So it's going to give us 3. Okay, now A4 will be 4 minus 2 plus 1/2 A4 minus 1. So it's going to give us A2 plus 1/2 A3. So guys, what we're doing here, guys, we're using the previous ones. Okay, the 2 is going to go first. A2 is 2, and A3 is going to be 3. So we're going to plug him in there. So it'll be 2 plus 1/2 times 3 will give us 2 plus 3 over 2. I believe it will give us what, 7 over 2. That's your answer, guys. There's my first 5 terms. We start with 1, and then 2, and then 2 again, then 3, and then 7 over 2. Okay, let me go back. Yeah, so again, it's 1, 2, 2, 3, and 7 over 2. Those are my first 5 terms. Okay, now, this is definition of factorial. If n is a positive integer, then n factorial is defined as n factorial is equal to 1 times 2 times 3 times 4 times ... n minus 1 times n. Hey guys, I like to use this formula instead of that one. It's the same formula. N factorial is equal to, you start with n, and then you keep subtracting 1, n minus 1, n minus 2, until you get to 1. These are the same, but I like to use the second one instead. And so here that the special case, that 0 factorial is equal to 1. Okay. Example here, example number 6. Writing the terms of a sequence involving factorials. It says write the first 5 terms of the sequence given by an equals 2 to the n over n factorial. Begin with n equals 0. Okay, so I'll plug in 0 for the n's are, so it's going to be 1 over 1 is equal to 1. Remember that 0 factorial, guys, is equal to 1. A1 is equal to 2 to the first power over 1 factorial will give us 2 over 1 is equal to 2. 1 factorial is equal to 1 also. Now A2, right, we're going to plug in 2 where the n's are. So it'll be 2 squared divided by 2 factorial will give us 4 over 2, which is equal to 2. Why? Because 2 factorial is equal to 2. Now let's find A3. Right, I'm going to plug in 3 where the n's are. So it'll be 2 cubed divided by 3 factorial will give us 8 over 6, which is equal to 4/3. 2 cubed, guys, is equal to 8, but 3 factorial is equal to 6 because 3 factorial is equal to 1 times 2 times 3. That's why it's 6, which runs off to, or reduces to 4/3. Now, A4 will be 2 to the 4th power over 4 factorial will give us 16 over 24. 24 because 4 factorial is equal to 24. See? And then we have 16 over 24 reduces to 2/3. Those are my first 5 terms. A0, A1, A2, A3, A4. Example number 7. Simplify factorial expressions. Okay, let's do A first. So A factorial is going to be 8 times 7 times 6 factorial. Why did I stop at 6 factorial? Because it's going to cancel the 1 in the bottom. And the denominator is 2 factorial is equal to 2 times 1. And 6 factorial, I don't continue, guys, because it's going to cancel. These are going to be canceled, right? So it's equal to 1, right? That's 1 right there. So 8 times 7 is 56. Over 2 will give us what, 28? The answer is 28. Now let's try B. Right, we have n factorial over n minus 1 factorial. Because if you notice, guys, the numerator is bigger, right? Because n factorial is bigger than n minus 1 factorial. So I'm gonna go from n times n minus 1 factorial over n minus 1 factorial. Those will cancel to 1. So n times 1 is equal to n. My answer is n. Okay. This is 61 from the homework. This is similar to B. Okay. Now here, guys, right? We have n plus 1 factorial over n factorial. Because the numerator is bigger than the denominator. So I'm going to try to simplify the numerator. N plus 1 factorial is equal to n plus 1 times n factorial. You see now, guys, the n factorials, they'll be eliminated, so that's equal to 1. So n plus 1 times 1 is equal to n plus 1. That's your solution. Okay, now, this is definition of a summation notation. Because I know that I'm going a little bit in a steady pace, in a fast pace, because I have a lot of material that I have to cover. Okay, and everything that I chose for this PowerPoint is crucial, guys. I cannot skip anything because every example is a little bit different than the previous one. So that's why I'm going like at a steady pace. Okay. Okay, now this is called the sum of the first n terms of the sequence is represented by the summation, right? From I is equal to 1, and it goes all the way to n. And we have AI. So here, guys, what we do, we're going to plug in 1 for I, and then we're going to go all the way to n. N is a counter. This tells me how far I'm going to go. So you go from A1 plus A2 plus A3 plus A4 plus dot 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 AN, because that's where it ends is at n. Hey, guys, I is the index of the summation. N is the upper limit, and 1 is the lower limit. Okay. Let's do example number 8. Okay. Because here, right, we're going to start with 1, and we're going to go all the way to 5. So it's going to give us 3 times 1 plus 3 times 2 plus 3 times 3 plus 3 times 4 plus 3 times 5. Because I start with 1 and I plug in where the I is, and then I go to 2, 3, 4, and 5, because 5 is the last number that I need to use. So here, guys, we can factor out a 3, and we're there with 1 plus 2 plus 3 plus 4 plus 5. It will be 3 times 15 will give us 45. The answer is 45. Okay. Now let's try B. Because B, we're going to start with 3, right? Because it says that we start with 3 and we go all the way to 6. So we're going to do 3, 4, 5, 6. We're going to do only 4 terms. Right? So first, we plug in 3 where the K is. And then we plug in 4. And then 5. And then 6. And just simplify. 1 plus 3 squared is 10. Plus 1 plus 4 squared is 17. 1 plus 5 squared is 26. And 1 plus 6 squared is 37. Right, we add them. The answer is 90. Okay. Okay, now we'll find the sum. Okay, here's this. I believe this is from the homework. It says find the sum. So right, so I'm going to go from 1 all the way to 4. So it's going to be like 4 terms, right? So to start off, I'm going to plug in 1 where the I is, and then I'm going to plug in 2. And then 3, and then 4. And then we'll do is add them. They'll give us 5, plus 4 times 2 is 8, 8 plus 1 is 9, 4 times 3 is 12, plus 1 is 13, and 4 times 4 is 16, plus 1 is 17. If we add them, guys, it's going to give us 44. That's the sum for that problem there. Now this is from the homework, from the book, 67. Like I share, guys, okay, we're gonna start with 2, and then we have to go all the way to 5. So for the first term, I'm gonna plug in 2 where the K is. On both cases of both binomials. Right, so this will give us 3 squared minus 1, right? So it's gonna give us, no, but let's do it first, and then we'll evaluate it. Then the second term is gonna be 3 plus 1 squared over 3 minus 3. then the next one's going to be the 4. This is going to be 4 plus 1 squared times 4 minus 3. What did I do here? Okay, here we go. It'll be 4 plus 1 squared plus 4 minus 3. And then, guys, here for the 5, I ran out of space, so I'm going to put it here at the bottom. So it'll be 5 plus 1 squared times 5 minus 3. Okay? This is going to give us 9, right? Or 3 squared times negative 1. This will give us 4 squared times 0. This will give us 5 squared times 1. This will give us 6 squared times 2. This will give us negative 9. This will give negative 9 plus 0 plus 25 plus 72. If we add them, it's going to give us 88. That's the answer for number 67. Okay, now here's the definition of a series. Okay, we did sequences already. Okay, now comes a series. Consider the infinite sequence. A1, A2, A1 is the first term, second term, third term, and so forth. The sum of the first n terms of the sequence is called the finite series, right? Because it has an end. Or the nth partial sum of the sequence that is denoted by A1 plus A2 plus A3 plus ... AN is equal to, is going to have an n. I mean, like an end. It goes from A1 all the way to AN. Number 2. The sum of all terms of the infinite sequence is called infinite series and is denoted by A1 plus A2 plus A3 plus ... plus AI, right? You see, it continues, guys, because it goes all the way to infinity. You start with 1 and it goes to infinity. That's why this is called infinite series. Number 9. Finding the sum of a series. Okay, guys, for the series, the summation of from I equals to 1 all the way to infinity, we have 3 over 10i. Okay, they want us to find the third partial sum. So I'm going to go from 1, 2, 3, and that's it. Okay, right? I'm going to plug in 1 for the i's, and then I'm going to plug in 2, and then I'm going to plug in 3. So this will give us 3 over 10, will give us 0.3. This will give us 3 over 100, will give us 0.03. And 3 over 1,000 will give us 0.003. If we add them, guys, it's going to give us 0.333. That's the answer. Okay. Now for B, guys, it's a whole sum. Okay. I mean the whole sum, which is infinite. Let's do it on the next slide. So here, guys, I'm going to go until I find a pattern. Okay. So here I stop at 5, right? Because this will give us 3 over 10 to the first power plus 3 over 10 squared plus 3 over 10 cubed plus 3 over 10 to the fourth power, right? And so forth. It just keeps going. And the next one will be 3 to the 10 to the 6th power, 3 10 to the 7th power, and so forth. Now, this will give us 0.3. 3 over 100 will give us 0.03. 3 over 1,000 will give us 0.03. 3 over 10,000 will give us 0.0003. And 3 over 10,000, because it's 5 zeros, will give us 0.00003. Check this out, guys. If you add them, it's going to be 0.333, right? It never stops. So this is the same thing as 1/3. Okay, because if you divide 1 by 3, it will give you 0.33333, and it goes on forever and ever. So the answer is 1/3. Okay. Hey guys, we're done with section 9.1. Now comes 9.2. 9.2 is called arithmetic sequence. Okay, the definition of arithmetic sequence is a sequence is arithmetic when the difference between two consecutive terms are the same. So the sequence is A1, comma A2, comma A3, comma A4, comma ... AN. Okay, now guys, if it's arithmetic, for example, A2 minus A1 has to give you the same difference as A3 minus A2, and A4 minus A3, and so forth and so forth. That's my difference. Okay. The number D is a common difference of the arithmetic sequence. Examples of arithmetic sequence. Because these are arithmetic. Why? Because the difference from 7 to 11 is going to be 4. From 11 to 15 is going to be 4, right? And so forth. So the difference is 4. So this is an example of an arithmetic sequence. I mean for A. Also for B, right? Going from 2 to negative 3, guys, is going to be negative, right? Because we can apply the rule here. What's negative 3 minus 2 will be negative 5. What's negative 8 minus negative 3 will give us negative 5, right? And so forth. So this is also an arithmetic sequence, and the difference is going to be 5. Okay, now, hey guys, this is the formula to find the nth term. The formula for the nth term. It says the nth term of an arithmetic sequence has a form an equals to a1 plus n minus 1 times d, which is the difference, where d is a common difference between two consecutive terms of the sequence and a1 is the first term. Okay, so here, guys, all we need is two things. We need a1, which is the first term, and we need the difference. Okay, this is one example. It says finding the nth term of an arithmetic sequence. It says find the formula for the nth term of the arithmetic sequence whose common difference is 3 and whose first term is 2. Right? Here, guys, everything's given to you. They give you the difference and they give you the first term. So my first term is 2 and the difference is 3. So all I'm going to do is plug him in. Right? Plug him into the formula. My a1 is 2 and my difference is 3. Now I'm going to distribute. It'll be 3 times 1 and 3 times negative 3. Right? Now I can combine like terms. The 2 minus 3 will give us negative 1. So my nth term formula will be an equals to 3n minus 1. That's your formula, guys, right there. That's what we're looking for. Okay, now, example 3. Because this is a little bit more trickier, guys. The other one, let's see if, yeah, it's a little bit trickier. It says, the fourth term of our arithmetic sequence is 20. And the 13th term is 65. Write the first 11 terms of this sequence. Because I believe this one, I'm going to do it in two ways. Because the first way is like the long way by drawing like a picture. Okay, it's going to be visual. And the second way is the way you should be doing it, because if you do it the first way, you might be there for a long time. Okay, let's see you guys here. Okay, no need to find the first term, right? I need to find the first term and the difference, so we can put it into the formula. Okay, check this out, guys. A4 is 20, and A13 is 65, right? So let's put all the 13 terms. That's the first term, the second, the third, the fourth, the fifth, the sixth, the 7th, the 8th, the 9th, the 10th, the 11th, the 12th, and the 13th. Right, so A4, guys, will be 20, which means it'll be the fourth term, which will be right about there. And A13, right, the 13th term will be 65. Okay, now, hey guys, from 20 to 65, right? What's my difference, right? It's going to be 9 terms, right? Because this is a fourth term. This is the 13th term, so it's going to be 9 terms. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 9 terms. Now, what's 65 minus 20? It's going to be 45, right? So we divide 45 by 9. Will give us 5, which means that's my difference. My difference is 5. Now, if you notice, guys, this is kind of visual, right? If the fourth term is 20, and the difference is 5, we're going to divide 20 divided by 4, because it's a fourth term, which will give us 5. I know my A1 is 5, right? And then we continue. This will be A1 is 5, 10, 15, 20, and so forth, right? But this might take you a long time, guys, to draw everything. And on the exams, you don't have, you don't have that much time, to do it this way. So here's the other way to do it, okay? Okay, now, right from 8, right, this is the 13th term is 65. We're going to put, the lower one, which is 8, the fourth term is 20. We're going to subtract them. What's 13 minus 4? 9. What's 65 minus 20? 45. We divide 45 by 9, which will give us 5. Okay, so my difference is 5. Now to find the first term, guys, I can go to either term, the fourth term or the 13th term. Let's go to the fourth term because it's easier because the numbers are smaller. Okay. Right, so A4 is equal to 20, which means I'm going to plug in 4 for the n is, right, to find A1. So A4, then I'm going to plug in the 20 for A4, right? So 20 equals to A1 plus 4 minus 1 times 5. This will give us 20 is equal to A1, 4 minus 1 is 3, 3 times 5 is 15. We subtract 15 from both sides, so A1 equals to 5. I got my A1, and I got the difference. Okay, so I'm going to plug in 5 for A1. I'm going to plug in 5 for the difference. Now, on the distributes, it's going to give us AN is equal to 5 plus 5n minus 5. Right, so 5 minus 5 will be 0, so my answer will be just AN equals to 5n. Now, to find all the terms, right, to find the first term, right, we plug in 5 where the n is. To find the second term, we plug in 2, which would be 10. Right, and you keep going. So it'll be 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, right? It says only 11 terms, right? So we stop there. Those are my first 11 terms. Again, guys, the first way that I did it, guys, is more visual. Okay, but that might require like a lot of time, especially if it says the 20th term is equal, say, to 600 or something like that, right? It's going to be tedious work. I mean, it can be done, but it's going to be a little bit more challenging because it's going to take a long time. So it's better to do it like this, guys. I mean, how I did it in the second part, do it analytically instead. Okay, because it'll be easier, I mean, in my opinion. Okay, now, example 4, using recursion formula. It says, find the 9th term of the sequence whose first 2 terms are 2 and 9. Okay, solution. Guys, they already give you the 2 terms, and you're saying that it's arithmetic. So to find the difference, we subtract 9 minus 2, which will give us 7. That's my difference. And my A1 is already given to you, right? So I already have my A1 is 2, and my difference is 7. So what we do is plug into the formula. A1 is 2, and my D is 7. So plug them in there. Now I'm going to distribute. This is going to give us 2 plus 7n minus 7. 2 minus 7 will give us negative 5. So it's going to give us AN equals to 7n minus 5. There's my answer formula. So now we're looking for the 9th term. Okay. So we're going to plug in 9 where the n is. Will give us 63 minus 5 will give us 58. The answer is 58. Now comes the sum of a finite arithmetic sequence with n terms is given by. So this is a formula, guys. Sn is equal to n over 2 times a1 plus an. So here, guys, okay, example 5, it says the sum of the finite arithmetic sequence, right? To find it, they give us 1 plus 3 plus 5 plus 7 plus 9 plus 11 all the way to 19. So I need to find a1, right? My first term and my last term, and also my n. Okay. I need to find a1, right? A1 is 1. A10th is 19. Why? Because it's 10 terms. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So n is equal to 10. When we have all that information, all we do is plug into the formula. So S10 is equal to 10 over 2, 1 plus 19, which will give us 5 times 20 will give us 100. That's your answer, guys. Again, you need only 3 things. You need a1, you need the first term, you need the last term, and you need your n. Okay. Example number 7. It says find the 150th partial sum of the arithmetic sequence. Okay. So here, guys, right? Let's see what the difference is. You need to find the first term and the 150th term. But first, guys, I need to find the answer formula first. Right? We know that A1 is equal to 5. You can see here, guys, right? What's my difference? Wouldn't it be 11? Right? You see, all these will be 11. So I know my difference is 11. Okay, now, so let's get the formula. I got my A1, my first term, and I got my difference. So let's plug them in. This will give us an is equal to 5 plus 11n minus 11, which will give us 11n minus 6. Now, let's find the 150th term. Right, so it's going to give us 11 times 150 minus 6 will give us 1,644. Now, right now, we got all the info. We got n is equal to 150. My last term is equal to 1,644. And my first term is equal to 5. Okay. So it's going to be S at 150 is equal to 150 over 2 plus A1, which is 5, plus 150th will give us 1,644. It's going to give us 75 times 1649. Use your calculator, and this is your result. 123,675 is your answer. That's the partial sum. Okay, now that was 9.2. Now comes 9.3. 9.3 is called a geometric sequence. Okay. Hey guys, for the definition, it's almost the same thing as the arithmetic, but instead of subtracting, like for example the second term and the first term and so forth, we're going to divide. So this is going to be division. So for example, we're going to get A2 divided by A1, A3 divided by A2, A4 divided by A3, guys, it's going to give you the same ratio, which is R, and R cannot be 0. The number R is the common ratio of the geometric sequence. Okay, let's do an example. Because these are examples of geometric sequence. Why? Because what's 16 divided by 8 is going to give us 2. 8 divided by 4 is going to give us 2. 4 divided by 2 is going to give us 2. So my ratio is 2. Same thing over here, right? And we start with 324 divided by 108 is going to give us 3. 108 divided by 36 is going to give us 3. 36 divided by 12 will give us 3. So my ratio is 3. And here, guys, right? So here, if we divide 1 over 81 divided by negative 1 over 27, it's going to give us negative 1/3. And negative 1 over 27 divided by 1/9 is going to give us negative 1/3. And 1/9 divided by negative 1/3 is going to give us negative 1/3. So my ratio is negative 1/3. Okay, now, hey guys, now there's also an instant formula, guys, for the geometric sequence, and it's how it shows here. The instant formula is equal to A1, R, which is a ratio, to the n minus 1, where R is a common ratio of the consecutive terms of the sequence. So every geometric sequence can be written in the form below. You see, A1, guys, is equal to just A1. A2 is equal to A1 to R to the first power. A3 will be A1 R squared, right, and so forth. This is crucial, guys, because it's going to help us, I believe, in one of our problems in the next, I think the next slide or 2 slides from now. Okay, now example 2. Writing the terms of a geometric sequence. It says write the first 5 terms of the geometric sequence whose first term is A1 equals 3, and the common ratio is 2. Okay, so they give us everything, guys, that we need. Okay, so plug them into the formula. An is equal to A1, which would be 3, to 2 to the n minus 1. Right? I guess here, guys, right? So they say to write the first 5 terms, right? So first, I'm going to plug in 1 for the first term. So it's going to give us 3 times 2 to the 0. It's going to give us 3 times 1 will give us 3. You see, that's my first term. Then we follow the same pattern, right? For the second term, it's going to be A2. Right, we're going to plug in 2 where the n is, so 2 minus 1 is going to be 1. So this gives us 3 times 2 to the first power, which will be the same thing as 3 times 2, which will give us 6. Okay, now, A3. We're going to plug in 3, right, for the n is. So it's going to be 3 times 2 times 3 minus 1 will give us 3 times 2 squared, which will give us 12. Check this out, guys. Okay, what's the pattern? Right? If the ratio is 2, it means that you can multiply like the first term by 2 to get the second one. You multiply the second term times 2 to get the third one. You multiply the third term times 2 to give us the fourth one, and so forth, right? So then A4 is going to give us, will be 24. Right? The fifth term, A5, is going to give us 48 because 24 times 2 will give us 48. See, guys, again, it's all about patterns. Okay. And the next term, which will be the sixth term, will be 48 times 2, right? And so forth. Now, hey guys, this is similar to the one that we did for the arithmetic that they don't give us A1, they give us two other terms. Okay. For example, no guys, it's not this one, it's example number 4. Here guys, this is straightforward. It says find the 15th term of the geometric sequence whose first term is 20 and the common ratio is 1.05. So they already give us everything that we need. So we're looking for the 15th term. Okay, let's plug everything in. A 15 is equal to 20 times 1.05 to the 15 minus 1, which would be 14 to the 14th power. Use your calculator. That should give us something like 39.59863,199. Let's run that off to our nearest hundreds. Will give us approximately 39.6. That's your solution. Okay, now here's another one. This is similar, okay, to example number 3. But here, guys, you have to find the ratio. They don't give you the ratio, no the first term. You have to get it from the sequence. It says find the formula for the nth term of the geometric sequence, and then you're looking for the 12th term. Hey guys, so what's 45, right? A1 is equal to 5, but what's 45 divided by 15? Is 3. 15 divided by 5 is 3. So that's my ratio. My ratio is 3. Okay, and we're looking for the 12th term. So let's plug in the 5 and the 3 for the first term in the ratio, and we're looking for the 12th term. So we're looking for A12. Will be 5 times 3 to the power of 12 minus 1 will give us 5 times 3 to the power of 11. Just plug it into the calculator. It should give us something like 885,735. That's the answer for example 4. Okay, yeah, this is one that I was talking about, guys, like similar to the arithmetic sequence. Okay, now they say the fourth term of a geometric sequence is 125, and the 10th term is 125 over 64. Find the 14th term. Okay, let's write out the info. Need to find R and A1. Okay, they give us A4. The fourth term is equal to 125, and the 10th term is equal to 125 over 64. Okay, again, guys, here we're not going to draw a picture, guys. Okay, like sketch it. We're going to do solve it analytically or algebraically. Okay, so here we go. We're looking for the 14th term. Remember that we're going to be using this. Okay, here's how. Because A10, right? A10 will be A1, R to the 10 minus 1. It's always one less. You see, if you notice, A4, the fourth term, is going to be A1, R3. A5 will be A1, R4. So A10 will be A1, R9. Right? And then for the fourth, right? For the fourth, it's going to be A1, R1, right? This is going to give us, right? Again, we're going to divide. Okay? Again, this is going to give us R to the 9th over R to the 3rd power. Right? And by using the exponents, when we're dividing with the same base, we subtract the bottom from the top, or the power in the denominator from the numerator. Right? So we're going to divide that, guys, and also we're going to divide here. So 125 over 64 divided by 125 is going to give us R6 equals to 1 over 64. If you divide 125 by 64 divided by 125 will give us 1 over 64. Now I'm going to raise it to the 1/6 power. Right? Now 164 to the 1/6 power, I believe is going to give you something like 1/2, I believe. Yes, it is 1/2. So I got my R. Now I need to find A1. Okay. So let's go to A4, right? A4 equals to A1, right? From here, right? A4 equals to A1, right? It's going to be R3, right? Because 4 minus 1 is 3. And we plug in the ratio. A4 is 125, so plug it in there, right? And the ratio to the 4 minus 1 will give us 3. Now, this will give us 1/8 on the right side. It'll be 125 equals to A1, 1/8. So I need to cancel the 1/8, so we multiply both sides by 8. Right, so it's going to cancel on the right side. So 125 times 8 will give us, I believe, 1,000. So A1 is equal to 1,000. So I got my A1 and I got my ratio. Just plug him in. That's going to be AN equals to 1,000 to the 1/2, right? To the power of n minus 1. Now we're looking for the 14th term. So we're going to plug in A14, which means I'm going to plug in 14 for the n's, which will give us 13. So it's going to give us 1,000 to the 1/2 power to the power of 13. And if you put that in the calculator, it should give you 125 over 1024. Okay. Again, guys, how we did this, right? We divide by using the concept here on top, right? So it's a concept, guys, and then we divide them because for the ratio is division, and for arithmetic is subtraction. Okay. Now comes the sum of a finite geometric sequence. Okay, and here's the formula. The sum is equal to A1, parentheses, 1 minus R to the power of n over 1 minus R. For example 6, it says find the sum, right? We need A1, we need R, and we need n, right? So here we go. So A1 is going to be 4. The ratio is going to be 0.3. And the n is going to be 12. Hey guys, I forgot to put a 2 here, guys. This is supposed to be 12. Okay, my bad. Okay. I repeat, this is supposed to be a 12 there. Okay. So now let's plug everything in. So A1 is 4. My ratio is 0.3. And my n is 12. Right? Just put it straight like that in the calculator. It's going to give us something like approximately 5.714. Okay. And I repeat, I did a mistake here, guys. Instead of a 1, it's supposed to be a 12, okay? Now comes the sum of an infinite series, geometric series. Now, the one before was finite. This is infinite. Okay, it says here, guys, if the absolute root of the ratio is less than 1, then the infinite geometric series is A1 plus A1R plus A1R squared plus A1R cubed and so forth. And it's a different formula, guys. For infinite series, geometric series, it's a different formula. Okay, and here's the formula. It's going to be A1 over 1 minus R. Hey, guys, so for this formula, guys, I want you to find just 2 things, A1 and my ratio, and that's it. Okay, so let's try A first. Right, they give us A1 is 4, and the ratio is 0.6. Plug into the formula, right? So the sum is equal to A1 is 4, 1 minus the R is 0.6. Okay, just put that in the calculator. It's going to give you something like 10. S equals 10. Now let's try B on the next slide. Okay, now guys, here. Okay, here, guys, find A1 and R. So A1 is 3, right? Let's divide 0.03 divided by 0.003 divided by 0.03 is going to give us 0.1. Then let's divide 0.03 divided by 0.3. It's going to give us 0.1. And then 0.3 divided by 3 is going to give us 0.1. So I know that 0.1 is my ratio. Let's plug into the formula, right? So I know my A1 is 3 and my ratio is 0.1. Let's plug him in. Use the calculator, and we get 10 over 3, or 3.33. Okay. Okay, now guys, I believe this is it for the for 9.3. Now comes 9.4. Hey guys, for 9.4, I only did 2 examples, okay? And I know it's already past time, okay? But I only have 2 examples, and this is very important, guys, because a lot of students didn't know how to do mathematical induction, okay? Hey guys, here's what you do, okay? It says let Pn be a statement involving the positive integer n. Because you have to meet 2 requirements. For the first one, P1 is true, which means when you plug in 1 on both sides of the equal sign, it should give you the same answer. That means that it can be proven by mathematical induction. And then you're gonna substitute k for every n. And after that, you're gonna substitute k plus 1 for every n. Okay. Let me show you what I'm talking about, guys. Okay, because some of the the wording here, guys, is a little bit kind of hard to understand. Okay. Okay, number 1, it's gonna be true for n equals 1. There's 2a. You're gonna assume value for sk, which means you're gonna plug in replace k for every n. And then here's what you have to prove, guys. You have to show true for sk plus 1, which means you're gonna plug in k plus 1 for every n. Okay. Here we go. Example 2, use mathematical induction to prove the formula. Sn is equal to 1 plus 3 plus 5 plus 7 plus ... plus 2n minus 1 equals to n squared. Okay, so the first thing, guys, we're gonna do, we're gonna prove true for n equals 1. Okay, so I'm gonna get the left side, okay, which is 2n minus 1, and n squared is the right side. I'm gonna plug in 1. Okay.
Olivia I. Sassy.
I'm gonna plug in 1. Okay, so if I plug in 1, it's gonna give us 2 times 1 minus 1 will give us 1. On the right side, 1 squared will also give us 1, which means I can move on. If this wasn't true, if say this was 1 and this was a 0, or vice versa, right? It went the same numbers, then it cannot be done by mathematical induction. Okay. Now we can proceed to step 2, which is on the next slide. Okay.
Olivia I. Sassy.
Okay, now guys, I'm gonna plug in k for n.
Olivia I.
Olivia, está ocupado. Okay, I'm gonna hey guys, sorry about that call. I'm gonna assume value for sk, which means I'm gonna plug in k for every n. Sk is equal to 1 plus 3 plus 5 plus 7 plus ... plus sk minus 1. You see, I plug in k for every n. Hey guys, and when you prove it, guys, you have to write everything, guys. At times, students, they don't want to put everything down. You have to write everything, or else it's wrong. Okay, you cannot skip anything. You have to do it just exactly like this. Hey guys, that means we're done with step 2a. Hey guys, this means, right, that we're done. I got this from an instructor at UTEP, okay, who showed me how to do mathematical induction, and I finally understood it. Okay, but he did this, that means that we're done with that step. Now comes step 3. Okay, I have to show true for sk plus 1. Okay, here guys, okay, here's what I'm gonna do. Right, I'm gonna write sk, right, which is 1 plus 3 plus 5 plus 7 plus 2k minus 1. Now I'm gonna add k plus 1 because that means that I have to show that the next term is also in there. So I'm gonna plug in k plus 1 right here and also on the right side. That needs to prove that the next term is also there. What term? This term here, right? This whole thing, guys, here is the next term. But when I do it on the left, I have to do it on the right. So I'm going to add k plus 1. Okay, now, because if you notice, right? If you notice here, guys, right? Hey, guys, what's 1 plus 3 plus 5 plus 7 plus ... plus 2k minus 1? Isn't it k squared? So I'm going to replace k squared for all this section here. So it's going to give us k squared plus 2k plus 1 minus 1. Okay, now guys, now I don't work on the right side no more. I only work on the left side. So the left side, which is k squared plus 2k plus 2 minus 1, has to equal to k plus 1 squared. That's how you prove it. So I'm going to leave my right side alone. Okay, I'm only going to work on the left side. So this gives us, guys, k squared will give us 2k plus 1. Now you need to factor it. To factor it, it's going to be k plus 1 times k plus 1, which will give us k plus 1 squared. You see, guys, they match. That means that's how you prove it. Okay? Let me do one more, and then we're done. Okay, now the same process, guys, okay? So I have to show true for n equals 1. That's my first step. Then I'm going to assume value for sk, which means I'll just plug in k for every n. And then 2b, guys, is the most important step because that's the one that's it's a little more challenging, guys, okay? Step 2b is a one that most students have a hard time doing it. But again, let me do it again. Number 9 with the same steps. So first I need to show true for n equals 1, right? This is my left side, and this is my right side. So if I plug in 1 on the left side, it's going to give us 2. If I plug in 1 on the right side, it will also give us 2 because 1 times 1 plus 1 will give us 2. Okay, so that means I can move on to the next step. Now the next step, guys, I have to assume true or valid for sk, which means I'm gonna substitute k for every n. Okay, now the next step, guys, is the most important one, guys. Okay, I have to show true for sk plus 1. So sk plus 1, guys, I'm gonna keep everything on the left side, and then I'm gonna add k plus 1 where the k is. You see, guys, all this from 2 all the way to 2k, guys, is my left side right now. Then this is proving that my next term is also going to be in there. Okay, the k plus 1. So you do on the right side, on the left side, you add k plus 1. So I have to add k plus 1 also on the right side. So instead of k, I'm going to put k plus 1. We have k plus 1. I'm going to put k plus 1 and then plus 1. So on the right side, it's going to give us k plus 1, k plus 2. Okay? So then, like before, hey guys, the 2 plus 4 plus 6 plus 8 plus dot 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 plus 2k is equal to, what? Is equal to k plus 1. So this is equal to k plus 1. I'm going to add it to 2 times k plus 1. Okay, now, hey guys, what do they have in common? The k plus 1. What's left? K plus 2. You see, guys, it matches the right side. So that's how you prove it. Hey guys, sorry guys that I took a little while, guys, like 10 minutes over. But this section, guys, is very, very time consuming. Okay, let me take you back to the host so they can let you know more about what's going to happen next week.
Thank you very much, Mr. Isasi. Thank you for your wonderful presentation. We do want to remind you all about our previously recorded sessions, which are available on our YouTube playlist. Today's session will also be available on that playlist later on. Also linked is a short survey to help us improve our TVE sessions. Please take time to fill it out, and we would appreciate you guys doing that. Before you guys leave, I want to share the TVE sessions that we will have next. We will not have Math Happy Hour next Friday, but we will be back on November 7th, where Math 1332 will be covering geometry, perimeter, area, volume, and surface area. And Math 2412 will cover the exam review for number 3. Today at 1 p.m., we will be back with student success topic, which will be covered victim advocacy, presented by Ms. Isela Grals. Thank you all for coming in today, and we hope you have a lovely weekend. If you have any questions, please feel free to use the chat box or open up your mic. Thank you, Mr. Isasi.
You're welcome, my friend. Thank you.